Okay, we're going to go over Friday's review quiz, Friday, April 24th, these 5 questions. So the first one is, when Ashley commutes to work, the amount of time it takes her to arrive is normally distributed with a mean of 52 and a standard deviation of 2.5 minutes. We want to find what percentage of her commutes will be between 54 and 56 minutes to the nearest tenth. So I'm going to draw a normal distribution. 52 is in the center, 54 and 56 is what we want between those two values. So it's saying between. We want this percent. We're going to use z-scores. So I'm going to find the z-score for 54. We need to figure out what this z-score is and the z-score for 56. The z-score formula is the value minus the mean divided by the standard deviation. So for 54, it would be 54 minus the mean is 52 divided by 2.5. We get a z-score of 0.8. And then the z-score for 56 is 56 minus the mean is 52 divided by the standard deviation, 2.5, and we get 1.6. Okay, so we need to look up those percentages in the z-score table. So z-scores represent how far the value is from the mean. So this is saying this 54 is 0.8 standard deviations above the mean, and 56 is 1.6 standard deviations above the mean. When we go to the table, so I'm going to look for the first one was 0.8. We have 2 columns, or 2 tables of z-scores. These ones are all negative. So we go to the other one. These are all positive, and I'm looking for a z-score of 0.8 right here. I just go to the first value because it's 0.80. The next one will be 0.81, 0.82, and so on. I just want 0.8 exactly. So 0.7881, I'm going to make that, to move the decimal place over twice and just make it a percent. So 78.81%. That means when we look up the percent in the table, that's telling us that everything less than that value is that percent. So 78.81%. That means everything to the left of the value I just looked up, everything here is 78.81%. Now I'm going to look up 1.6, and that'll tell me everything less than 1.6. And then I'm going to subtract the 2% because I just want what's between the two. So if I go to the z-score table again, I'm going to go to 1.6, and again, just the first column, because I want 1.60, is 0.9452, so 94.52%. 94.52%. That means everything to the left of 1.6. So again, I just want between these 2%, kind of like the overlapping part. So I'm going to subtract the percents. 94.52 minus 78.81%, and we end up with 15.71%. When it said round to the nearest tenth, that's the first decimal place, so 15.7%. When we were finding between two values, we found the z-scores, that was here, and then we looked up the percents in the table, that was here, and then we want to subtract the 2%, that was here. All right, number 2, on a standardized exam, the scores are normally distributed with a mean of 57 and a standard deviation of 10. And we want to find the z-score, not the percent, so we don't even have to use the table. We're just going to find the z-score. Z-score formula, again, is the mean minus, the value minus the mean divided by the standard deviation. And we want to find the z-score for 75. So 75 minus the mean was 52 divided by 10, and we get 1.8. Just to show what this means, or what this represents, we have a normal distribution, so scores are normally distributed. The mean is in the center, 52. 75 is going to be way over here, and that z-score, we converted 75 to a z-score, is 1.8, and that means that value 75 is 1.8 standard deviations above the mean, away from the mean. All right, number 3, on a test that has a normal distribution, a score of 40 falls 3 standard deviations above the mean. I'm just going to go ahead and start drawing a normal distribution. I don't know what the mean is yet. In fact, that's what we're going to be trying to find, so I'm going to put mu in the center. 40 falls 3 standard deviations above the mean. So 1, 2, 3, there's 40. 36 falls 1 standard deviation. This was supposed to say below, and if you took the test or the quiz later in the day, I fixed it and it did say below. So sorry if you took it in the morning, it still said above. It was wrong. Sorry, but it's down here, 36. And then determine the mean. We want to figure out what the mean is. If I just count these, it looks like they're all 1 unit. 36, this is 37, 38, 39, 40. So our mean is 37. Number 4, the weight of oranges growing in an orchard is normally distributed with a mean weight of 6 and a standard deviation of 1. I'm going to start drawing it. It says using the empirical rule. So that's the 68, 95, 99.7 rule. What percentage of the oranges from the orchard weigh between 3 ounces and 9 ounces? So I'm going to go ahead, since I'm using the empirical rule, I'm going to go ahead and mark 1, 2, 3 standard deviations in each direction, and the standard deviation is 1. So every time I go 1 standard deviation in each direction, it's just 1 unit. So 7, 8, 9, 5, 4, 3. I want the percent between 3 and 9. Those are 3 standard deviations from the mean in each direction, which is 99.7% according to the empirical rule. And last one, the mean July daily rainfall in Waterville is 10 millimeters, and the standard deviation is 1.5 millimeters. This data is normally distributed. What's the probability that a day in July will have more than 8 millimeters? So 8 down here, because it's to the left of 10. It's smaller than 10, so we know it's to the left. And we want more than 8, so that is this way, to the right. I want that percent. I need to find a z-score first. So it's the value that we're looking for, 8, minus the mean is 10, divided by the standard deviation, 1.5. We're going to get negative 1.33. Make sure every time you're to the left of the mean, we're below the mean, we're getting a negative z-score. That makes sense. We're less than the mean. The z-score is measuring how far above or below the mean that value is. So if we're below, we need a negative z-score. So now I'm going to go to the table and look up negative 1.33. The z-scores are over here when they're negative 1.3, and then if I go to the first number, that's negative 1.30, negative 1.31, negative 1.32, negative 1.33, so it is 0.0918. I'm going to convert that to a percent, 9.18%. But when I look at the table, that gives me the value less, or the percent less than the value, so 9.18% is this way. If I want the other direction to the right, I'm going to do 100% minus 9.18%, and that is 90.82%. So basically, every time you look at the table, it's giving you the percent to the left. We don't want the percent to the left in this case. We want the percent to the right. We want this way. So this 90.82, that's that part that we want that's greater or more than 8 millimeters.